All right, this is the check for understanding for lesson 8.4, the one when we determine how much of the earth is covered by water, and we threw the globes up in the air and caught them. All right, this story is, according to Common Sense Media Survey, 910 randomly selected U.S. teens, 57% reported that they watch TV every day. Watching TV includes watching programs from a broadcast or a cable network on a TV set, watching shows on a DVR or streaming shows, pretty much any way you can get your shows, like Netflix. Number one, construct and interpret a 99% confidence interval for the true proportion of teens who watch TV every day, who report watching TV every day. So we're going to do state, plan, do, conclude. State is simply, what is our goal here? Our goal is to make a 99% CI, that's confidence interval, for P, and P is the true proportion of teens who watch TV every day, who report watching TV every day. TV every day. Okay. The plan. We like to name what we're doing, and we'll get a little bit more used to these titles, but this is called a one sample Z interval for P. Some of that's kind of self-explanatory. It came from one sample, and it's an interval, and it's a proportion. We'll get more into like what it means by Z interval a little bit later. Then we need to check our conditions. One, is it random? Does it say up there in the description anywhere that it was random? You know, it says a survey. Oh, right there, randomly selected. So check they were randomly selected. You could maybe just highlight that. Be like, yep, says so. Right there, just kind of take the easy way out and draw an arrow. Number two, is it approximately normal? For that, we check large counts. So you take your successes and failures. There were 910 in the survey. 57% said, so 57% is my P hat. So if I multiply those are my successes. So I had about 518.7 teens that, this is the ones that watch TV every day. Those are my successes. And then my failures would be 910 times 1 minus 0.57. And that number would be 391.3, which is greater than or equal to 10. I should say that over here too. So we're good on both of these. So random, check. This one's more than 10, this one's more than 10, so it's normal. The third one is the distribution normal? Or sorry, is it independent? It's the 10% rule. So the sample size was 910. If I do 10 times 910, that's 9,100. That is less than the population, so then you need to ask yourself, what is the population here? The population would be U.S. teenagers, and that's true. There's far more than 9,100 U.S. teens. U.S. teens. So we're good on all three of these. Check, 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 so I can go ahead and do it. I like to list the actual formula first. P hat plus or minus Z star times the square root of the P hat times 1 minus P hat divided by N. All right, let's get into that then. What is P hat? Well, it's 57%. So that's 0.57. I'll highlight them so they match. Z star is from a 99% confidence interval. It's on your quick notes from yesterday's lesson. For a 99% confidence level, Z star is always 2.576. So that matches that, okay? Then this big piece here, this is the standard deviation of the entire sample. So that's the square root of why do I keep writing 37? 0.57, 1 minus 0.57, divided by the sample size of 910. So essentially, I think the middle is 57%, and then I'm going to go up and down, plus or minus, about 2.5 standard deviations to get my interval. If you take your time on your calculator, you will get 0.57 plus or minus 0.042. Excuse me. So the margin of error is this number. This is the MOE. And then if you actually add it and subtract it, you'll get as low as 528 and as up to as high of a number as 0.612. So we are 99% confident that the true proportion, just fill in these blanks on the sentence frame, of U.S. teens who watch TV daily. Do not shortcut these, okay? Is between 0.528 and 0.612. Okay, so we did all the grunt work. State plan do conclude. Number 2, based on the interval, is there convincing evidence that a majority of U.S. teens would report watching TV? A majority means greater than or equal to 50%. As I look at my interval, this entire interval is above 50%. So yes, there is. Since every possible value in the interval is above 0.50, we can conclude the majority of kids, of teens, watch TV daily. Oofta. Last one. What if they wanted to reduce the margin of error to 1%? Because right now the margin of error was about 4%. Okay? This piece here is the margin of error. So we're going to redo it, but I am going to make the margin of error 0.01 because it's 1%. The z-star does not change, 2.576, and the p-hat does not change. Okay? The p-hat is still 57% and 1 minus 57%. The only thing that's changing is n. I don't know what n is. And if I can solve that, I can get my new sample size. They're going to have to ask more teenagers to get this number large enough. Here we go. So here's the process on the calculator. You're going to take 0.01 divided by 2.576. Okay, that would be dividing this number out. So it's gone. Now we're here with 0.00388 equals the square root of all that stuff. And at this point, you got to get rid of the square root. So you're going to square both sides. So I can just square my answer. Oh, yuck. It's getting really small. That is scientific notation. 1.5069 times 10 to the negative 5. And what I'm left with is this. The square root's gone. At this point, I like to just play a little trick on the equation. I'm going to multiply both sides by n, which essentially just moves the it just moves this n over there. And so those are gone. Okay. By the way, I am not going to even try to do anything with this. I'm going to leave it on my calculator so I can keep using it. I'm going to then get what is the decimal of this? I can do that now. 0.57 times 1 minus 0.57. So what I have now is n times 1.5069 times 10 to the negative 5 equals 0.2451. And the last thing I got to do is divide over this standard deviation. Sorry, this scientific notation. Now notice, as I've been doing this, you guys, I have not rounded anything on my calculator. So I'm never going to round these things off until I have my final answer, because it makes a difference. When you're talking about significant figures that are this small, you can't round this stuff. You should not. So I'm going to take the answer of 0.2451 divided by, and then I'm going to go up here and I'm going to grab the entire scientific notation answer, and there I have my answer for n. 16,264.28. Now, you always round up. Well, round up, okay? Because if you round it down to 264, it would not be quite enough. So I'm going to say 265 people. So you can probably shortcut some of this in here, but I showed you the entire nitty-gritty. Okay? So, it says how many additional teams do they need to select? Ooh, curveball. This is how many people they need to select, but how many in addition? Because they originally started with 910. Holy cow. So they have to ask a whole lot more. 16,265 minus 910. What am I doing? Hello. Is 15, so 15,355 additional teens need to be surveyed. That one was a doozy, folks.